Yeah, I think so now. All right, here we go. So there are two types of division. Just so you know this, there are two types of division when it comes to polynomials. One of them today is called long division. You actually started long division back in about what grade? Third, fourth, fifth. Okay. This would be Monday. You come back here next Monday, and we do this one, which is called synthetic division of polynomials. Okay. I can almost guarantee you, you're gonna like synthetic better than long. Okay. Long division started in third grade. By the time you got to fourth and fifth, you were pretty good. By sixth grade, seventh grade, they started saying just use a calculator because long division is long division. It takes a while. So here's a quick problem right here in your notes. I kind of did it for you. But let's just take a look at it. When it comes to division, they asked you to write a division symbol like this. 3 goes into what number? Let's just put 19. Okay, so this is how it started way back in whatever, third grade. Your teacher probably said 3 goes into 19. How many times? And probably said to you, don't look at the ones column. Just look at this tens column. Does 3 go into 1?
No.
No. So you might have been told, put a 0 there. Okay. Then they said, well, if it doesn't go to 1, go next door. Now it's 19, right? 3 goes into 19?
6.
6 times. Okay, once you knew it went in there 6 times, what'd you do with the 6?
You 3
And
times
3.
6. And
You did this, didn't you?
yeah.
You took 6 times 3 and we got 18. Okay, you put it underneath the 19, then what'd you do?
Subtract.
Okay, then you changed it to what? Its opposite, negative 18. Even though your teacher didn't say that, that's what you actually did. Okay, you changed it to negative 18. Then you got what?
1.
1. Now that 1, oh, I thought you were in.
Yes.
Okay, sorry. What's that 1?
Remainder.
Okay, that's your remainder. Okay, how did your teacher tell you to write that? 6 is your answer.
6 remainder 1. R1.
R1? Okay.
Yeah.
So your third grade teacher might have said that. You have a remainder of 1. Okay, so put R1. Okay, then you got to 4th grade, 5th grade. You started talking more about fractions. Then your teacher might have said your answer is 6 and 1/3. Okay, so that's what your 5th grade teacher started telling you, right? Okay. Then, as I said,
Volunteer.
later you got so good at this, they said use your calculator, okay? And then you started doing that. Okay, now you've kind of lost your skill a little bit, so hopefully we can regain it. Now, come back here again. This problem that I just did, all these numbers are given names. The number inside is called the what? Dividend. What you're dividing by is called the divisor. Your answer is called the
Quotient.
The number at the bottom is called the remainder. Okay. All those names are kind of in here, but they're in function notation. I'll talk more Monday about this, okay? We're not going to talk about this, okay? All right. One last problem before I move into polynomials. It's right here. Take this number, 132, divide by 4. I did all the work on your notes. I got 33. My remainder was what, though? 0. So 4 goes into 132. What would you say? What? Evenly. 4 goes into 132 evenly. Somebody last period said perfectly. Well, guess what? Because the remainder is 0, we know that 4 right here and 33 right here are factors of 132. So that would mean this number times this number, right here, 4 times 33 must give us what?
32.
The dividend, the number inside. Okay, well guess what? When you start talking about polynomials, if you get 0 as your remainder, then this number right here, 2x plus 1, becomes a what? A factor. This could be a factor of this if the remainder is what?
0.
0. Okay? It doesn't always happen. You don't always get remainders of 0. Okay. So here we go. We're going to get started with polynomials. Okay? Right here. 2x plus 1. How many times will it go into this 6x squared plus 7x plus 2? How many times? Well, here's what you do. Everybody, this is where you really got to zone in. No, not zone out. Zone in. You only care about the leading term. Not the 1, but the 2x. All you care about is the 2x. How many times will 2x go into the leading term, 6x squared? This is where you come over here and go like this. This is on scratch paper. How many times will 2x go into 6x squared? Can you tell me?
3x.
3. 2 goes into 6 3 times. This x would cancel with one of the two. Answer's 3x. That's the answer. Remember how up here it was 6? Well, now it's 3x. Where do I put this 3x on top?
Above the 6x.
This is an x term.
So above the 7x.
Above the 7x. Put it above the x term. If you're getting an x term, stick it above the x term. Okay? Now, what did you do once you knew the answer? I heard somebody say it. Multiply. You take that number, 3x, 6x, times this, times that. Here we go. Why did I put 6x? Because the answer was 3x. Why did I do that? I don't know. Let's try that again.
Okay.
Sorry. That's a 3x.
You're sure there's really that?
3x times 2x is what? What is it? 6x squared, isn't it? Okay. 3x times 1. 3x. Okay. Got that? It's just what you did in 3rd grade, but you're getting polynomial answers. Okay. Now what did we do with this number?
Make it the opposite.
Yeah, but I was hoping you'd just say we subtracted it from the number above. So when you subtract, you're subtracting a binomial, right? But when you subtract, don't you run this through? Don't you run this negative signs through?
Yeah.
And it makes this what? Negative and negative. And once you run that negative through, just add the two terms. What's 6x squared take away 6x squared?
0.
Nothing. What's 7x take away 3x? 4x. And then you have to bring down this number you never dealt with, the plus 2. Just bring down the next number and start over. Division is just the same process over and over until you get to your remainder. Okay? Now you look at the first term, 4x. You divide it by the first term, 2x. Come over here. Just do a quick division. What's the answer?
2.
2. So 2 goes above
2.
the constant 2. Okay? And now what do? Multiply. 2 times 2x. 4x. 2 times 1. 2. Subtract. And when you subtract, you're subtracting a binomial. Run that negative through twice. Come up with what?
4x minus 2.
Negative 4x and negative 2. And make that a plus. Add down, get what? 0. Okay. 0 becomes your what? It's your remainder. And I just want you to know this. Whenever you get a remainder of 0, it means that number goes into that number evenly. And if it does, then you know this and this. These two numbers, they're just factors of this. So they say down here on the very bottom, because the remainder is 0, we know that 2x plus 1 and 3x plus 2 are factors of the dividend. Okay, so if you write it as this factor times this factor, your divisor times your quotient, you should get what you started with. 6x squared plus 7x plus 2. So the nice thing about long division is, if you actually divide it out and you get 0, then you know it's a factor. And you could just write the factors out and you'd be done factoring. Long division is a process. It's just like riding a bike. You do it once, twice, 3, 4 times. You got it. You're riding your bike forever. Okay? So you've done it once. You're kind of ready to fall off your bike now. We got to get back on, and we got to go again. So here comes the next problem, right here. Take that number, divide by x plus 5. Okay, I'm trying to give you a little time to start. Because if I'm always starting for you, you're relying way too much on me. All you care about is the x. The first term in your divisor. How many times will x go into the first term? 4x squared. I did it over here. Anybody tell me? This is 1.
4x.
Yeah. 4 divided by 1 is 4. X to the first. X to the second. I hope you guys are thinking like this.
Yep.
X squared is just xx, isn't it? So really this just cancels with this. What's left? X. It's 4x. Put the 4x here. Okay. Put it above the x term, the 23x. Multiply here. Here. You get what? 4x squared plus 20x. Gotcha. Okay. When you multiply, then the next step is subtract. Here we go. We're going to subtract everything, which basically will change this into negative, this into negative. This becomes addition now. So you get 0, nothing. You get what here? 3x. You bring down the next number. Good? Okay.
Instead of doing like plus, negative,
Yeah.
just make it to a negative.
As long as you understand, because these were both positive, this went negative. But what if they would have been negative? Then you got to change them to positive, right? Just change it to the opposite.
Okay.
That's all subtraction is. Subtraction is really just adding the opposite.
Under the, will they always be like 2 of the same? Do you get
This one right here?
those 2? That,
Yes, always.
The A and the, no, like, the A and the B term under the, like, the divising kind of, like 4x squared and like 23, will they both be positive or negative? Always.
Positive.
Do you get what I'm saying?
Not really.
Like when you, because you know if you convert the bottom to negative so that it like factors out, right? Or whatever, like, not factors.
Well, this term and this term, no matter what, if you're doing it right, these two terms will do what?
Cancel out, but the other one.
They'll always cancel out. Okay? Yeah, I just don't quite
That's okay.
hear it or see it. Okay, let's do it again. Ready?
Who said?
How many times will this x go into that 3x?
3.
Okay, quick division. These x's just what? Cross out. 3. So it's plus 3. 3 times this, 3 times that gives you what?
3x.
Plus 15. Okay. All right. Subtract. But subtraction is adding the opposite. Negative, negative. Yes, the x's disappear, but the constants add up to what? Negative 30. 1, which becomes your remainder. So your answer is 4x plus 3 with a remainder of negative 31. And here's how you write it. Minus 31, still divided by what though? The divisor, x plus 5. Okay? So when you get a remainder, you just say plus 31 or minus 31 like I did. But then you got to remember, you're still trying to take your remainder and you're still trying to divide it by your divisor. Okay? All right? Now, just a quick question. Is x plus 5 a factor of this?
Yes.
I thought to be a factor, it's got to go in there evenly, 0, like remainder 0.
No.
No, it's not a factor.
Come on,
Okay. To be a factor, your remainder has to be what?
0.
0. Okay. Move on. One more. This is where you should be like way ahead of me.
What we just said.
You should not be trailing or just right with me.
You're just chilling.
Right now you have probably the first term on top. I'm looking. We have on top.
Alright.
We have on top, right?
3x.
Okay.
Can I give you a sheet of paper right now?
3x good.
Three x times x is 3x squared. It's x times x is 7, negative 21. Not sure where you get 26.
Wait, so when you do this,
I'm not sure if that's 50's right.
I think that's what I don't know whether the series was 15 or
yeah, it's like plus 8 right there. Yeah.
Okay. Yes. Right here. Okay. All right. Ready? You care about only one term. It's the first term. X. How many times will x go into the first term? 3x squared. Well, this is 3 over 1. 3. X squared divided by x. X. I was looking for 3x. A lot of you had 3x. Okay. Where would you put it though?
The middle.
On top of the x term, right? Multiply. Multiply. This would give you 3x squared. This would give you negative 21x. Draw your line and subtract. When you subtract, it's like adding the opposite. Change the sign. Add down. Gone. What's this?
Negative 8x.
Okay. Bring down this. Okay. And start the process over. Okay. How many times will x go into what? Negative 8x. Well, I think you can see that these x's are going to disappear. Negative 8. Okay. 3x minus 8 on top. Take the negative 8, run it through. Negative 8 times x is negative 8x. Negative 8 times negative 7. Positive. Okay. Okay, now you know you're going to subtract. So if you're going to subtract, it's like adding the opposite. Okay? What happens?
Cancel out.
The remainder is 0. Oh, so if the remainder is 0,
Or factor. It works.
is it a factor?
Yes.
It's a factor. So then, if it's a factor, then I should know there's a factor times another factor to give me the original number. X minus 7 times what? 3x minus 8 is the answer. So if you FOIL that out, will you get this? Not most likely, for sure. For sure.
Possibly.
Okay. No, not even possible. Turn page. Turn page. The next problem says, is x squared plus 1 a factor of blah, 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 blah? Use long division. For you to say yes or no to that, what would a yes mean?
It is a factor.
If you're going to say yes, how come you get to say yes?
Because x squared plus 1 is a factor of the long number.
No.
There's no remainder.
The remainder is what?
Zero.
0. If you're going to say yes, the remainder is 0. If you're going to say no, the remainder is not 0. Okay, you have to get going. Now this one has a wrinkle to it, a little twist. Be careful. Any guesses what the wrinkle is?
It's long.
You need an x.
Okay, what?
You need an x.
Yeah, you see that I left a blank, right? Okay, here's why I left a blank. When you guys write numbers, would you tell me how to write this number?
Okay.
2005.
2005.
2005. Why do I need zeros?
Because they're placements.
Because they're placed that they hold
So-
they hold the place of something. That's the what column?
Tens.
Tens column. That's the what column?
Hundreds.
Hundreds. I'm trying to tell you, you have 5 ones, you have no tens, you have no 100s, but you have 2 thousands. So there's 2 thousands and there's 5 ones. That's 2005. This is important. Without these 2 digits, this number wouldn't be 2005. You have to put what here?
0x.
0x. Okay, if you didn't put that, put it now, and then start working the problem. You're gonna get it wrong if you don't put it.
Yeah.
Okay, so my first question is 3x to the 4th divided by x squared.
Wouldn't that be 3x squared?
Yes, it is. It is 3x squared. Have you figured out the secret with exponents? 4
Minus 2.
minus 2 is 2. That's all it is. It's just subtraction. Okay, so this 3x squared better go above the 12x squared. There you go. Right? I put it above the same term, yeah. 3x squared what? Times this. And this.
Well, it's
Gives us
3x.
to the 4th. Then it gives us,
3x squared.
you better line it up under the x squared term, because if you put it under the x cubed term, you're going to mess it all up. I know, I'm telling you, this one's tougher. It's got a wrinkle to it. You might, if you like to see place value, go ahead, put what here?
Plus 0x cubed.
Yeah, you can put a 0x cubed if you like to see it. If you don't care, well then don't put it. But you have to know it's 0. Okay. Oh, I forgot something. Positive 3x cubed squared. Let's subtract. To subtract, you change the signs of everything and then you just add. Negative. Don't worry about this one. Negative. What's the answer? Nothing. Followed by what? No. Negative 4x cubed plus 9x squared. Right? You can bring these down if you want. You don't have to until later, but just not, I don't wanna lose them, so I'll bring them down. Next question, how many times does x squared go into what?
Negative four x.
cubed.
Okay, x squared goes into negative 4x cubed. This is 1,
Negative 4x.
negative 4. These two x's would cancel with 2 of the 3. There'd only be 1 left. Negative 4x. Put it above the 0x. There you go. Multiply. Negative 4x times x squared is negative 4x cubed. Negative 4x times 1. Negative 4x. Put it under the 0x. Right? Put a place value in there just so you can see that. You know you're going to subtract, so let's go ahead and subtract, but that's just adding the opposite. Change everything to its opposite. Okay, this is nothing. This is what? 9x squared. What? 4x what? Plus 5. We're almost there, guys. Okay, hang on. Long, yes. Complicated, okay, 9x squared what? Divided by
9.
x squared. 9 over 1 is 9. And x squared over x squared cancels. 9 is the answer. 9. 9 times x squared is 9x squared. 9 times 1 is 9. If you want to put the 0x, put it in. Subtract. Well, subtraction is the same as adding the opposite. Okay. Subtract now, or add down, I guess. What do you get? 4x minus 4. Okay, you got to a point where if you take x squared and you divide it into 4x, guys, if the denominator's exponent is bigger than the numerator's exponent, you can't do it. You're done. You're just done. This becomes what? This is your remainder. Okay? The remainder can be written. Okay, I'm going to go up here and do this. Here's what you'd probably say. Plus a remainder of 4x minus 4 over. Guys, I'm trying to talk and people are just talking freely. Stop talking. Okay? This would be the remainder look. But the question was, is it a factor? No, without a 0 remainder, it's not. So you would say probably no. Okay? It's not a remainder. Now this last problem down here, I'm not going to do it, but I just want you to set it up as though you were going to do it. And let's just take a look at how nasty this one would be. Okay? All right, the question is, just a book assignment. Did I say we're back on track?
Yes. Yes.
Our calendar's back on track. I caught you.
So it's on
Friday's assignment, it's a book assignment. Okay. Okay.
He didn't say that to the rest of the class because
Okay,
Ethan
listen
was
now.
saying to me and asking about it. He said that we're back on track.
I said it?
Yes.
Oh, I said it.
You said it to Ethan
Ethan?
because he's not here and he was asking about the assignment. And
Oh, yesterday?
Yes, and you
Oh.
said that we're back on track, so it's on the calendar.
Okay. We're back on
Like you
track.
didn't say it to anybody but him, and I heard it.
Okay, good. Good, I'm glad you heard it.
No, that's what I was trying to say.
All right, ready? Here we go. Well, I want you, you're not going to do it, but I just want you to set it up. Is x minus 2 a factor of this polynomial? And then you know to say yes if it's remainder 0. If it is, write p of x, your polynomial, as the product of the two factors. Okay, so here it goes. If you're going to divide by what? X minus 2. I just want to know, how would you write that inside there? X to the 5th minus 32.
X to the 5th plus 0x to the 4th, and so on.
And so on. Okay. I hope you mean by and so on like this, right?
Yeah.
Okay.
Just do the same.
Okay, and then, you know, it actually looks like a really small problem. It just looks like x squared minus 32 looks small. But by the time you finish this, you would have almost the whole paper filled in. And by the way, the answer it has a remainder of 0. So this would be a what? This would be a yes. Okay. And then they want you to do this. They want you to write your polynomial as the product of the two factors. Well, wouldn't it be what then? What two factors?
Binomial.
X minus 2 times what?
X to the 5th minus 32.
X to the fourth.
No, wouldn't it be your answer?
Yeah.
Whatever your answer is, up here. But we're not doing it. All I'm saying is, that's what you would do in your book today, when you get to your assignment. They'll say, write your polynomial as a couple factors. Okay? Peach, green, blue, and maybe an occasional purple. Anybody? Occasional purple. You know that purple one had 5, 2,
Yes. AP's playing on Sunday.
At least.
I was
Like my friend's husband, they uses It's all just gonna come back to finding factors.
I'll go.
That's really all this whole chapter is.
I still have mine.
You still have the whole thing? Oh.